Chapter 8, Polarity Lab, that you will be completing over Thanksgiving break. What we have set up are 4 burettes. The first one, over on this side, is water. Then we have acetic acid. Later, I will show you our last 2 burettes, which have isopropanol and hexane in them. Those will come later. Our first test for polarity is to test whether or not these 4 liquids react to a charged balloon. So I've taken a standard balloon, charged it by rubbing it up against my head, provide some electrons. I'm going to open the burette and let the first burette, which is water, start to come out. And you can see it's a normal straight stream of water. As soon as I bring the balloon close, the water stream starts to bend a bit. I can do it from this side as well. Go ahead and turn that off. We're going to test the same thing with acetic acid, aka vinegar. This is also a carboxyl functional group, which means that this smells putrid. I'm going to turn this on. Normal stream. Charge my balloon again. This also attracts towards the balloon. Do it in a different direction as well. Turn that off. Next, we have the isopropyl alcohol, which is part of our hydroxyl group and has a medicinal smell to it. Let that start to run. Charge the balloon. Of course, now we're going to have burette problems. Still works though. So even though the stream isn't the greatest, you can still see that it gets attracted. Do this one more time. Very attracted. Turn that off. And then finally we have hexane in our last burette. And hexane is part of the alkane group, which is sometimes called no functional group and also has more of a gasoline type smell. So if we turn that on, we have a normal stream. Charge my balloon one last time. And this really doesn't have any effect. My stream stays pretty normal for the most part. So no effect for the balloon. What you fill in your data table is for water, it attracts to the balloon, acetic acid attracts, isopropyl alcohol attracts, hexane has no reaction. Next, we're going to test our 4 liquids on wax paper. We're looking to see if the drop stays rounded or if it flattens out. So you can see with our water, this stays as a nice round drop. I can actually move this around on the wax paper if I move the wax paper around. We're going to test the same thing for acetic acid. This also stays as a rounded drop. Still moves around quite nicely. Now we'll do the same thing with isopropyl alcohol. This one makes it really hard to see, but this flattens out and does not stay as a rounded drop, which is why it's so difficult to see. So this one flattens. And finally, for hexane, this one also flattens and makes it very difficult to see, but the fact that you can't see it is just evidence that this flattens out on wax paper. Last, I want to explain what's happening in this lab. So what I've drawn here is a representation of water interacting with the charged balloon. And you can see the water coming out of the burette and it's attracting towards the balloon. And then this is kind of a zoomed in version. So you can see your water droplet with an H2O molecule, 2 H's, 1 O. And based off of our chapter 8 notes, we know that there's a partial positive and a partial negative side to every polar molecule. This is the partial positive side with the hydrogens. This is the partial negative side with oxygen. The balloon has electrons from being charged when I rubbed it on my hair. So the partial positives attract to the negatives of the balloon, which is what causes that stream to curve. Finally, the last thing here is showing how 2 water molecules interact in a sample. We have the partial negative side of water and the partial positive sides of water with the hydrogen attracting another molecule. The partial negative of this oxygen is attracted to the partial positive of this hydrogen. We could continue to build the chain depending on how many water molecules we needed to represent. If you have any other questions about the Polarity Lab, please feel free to reach out to me via email. Otherwise, your job is to finish the remainder of this lab, and it will be due when we return from Thanksgiving break. Have a wonderful holiday.